அதுக்குள்ள you have deep learning, you have Gen. Continue. Yes. You can read, it's okay. Just like that, you can view it and read. உங்க பேர் என்ன? யோசிக்கிறீங்க உங்க பேர் என்ன?
ஆகாஷ்.
Continue. Yes.
Aditya. Hello.
Hello. On. Continue.
Hello. Alexa is Samyata, Cloud Base, Voice Service. Assistant is visual assistant that interact with Alexa is Amazon based assistant visual assignment that interact with user for natural language processing.
You should clap for it. யார் கிளாப் பண்ணலையோ அவங்க தான் கண்டினியூ பண்ணணும். Okay, enough. Okay, fine. Answer on no clap over. We have to understand why we go for deep learning. See, deep learning one day for an answer, but it cannot be precise. For example, if you speak in English. Okay, listen. See, I'll open maybe if I'm open only for a certain time. It cannot be open throughout. So there'll be a certain timing there, and also I'm searching for the blocks there, or if that's a cancer detection system. So if the cancer cells, no, I have to eradicate it completely. I can't leave even a single cancer cell. If there is one more possibility. If that's a normal cell, if I kill the normal cell, that is again a problem. So it should be very precise. In such places, machine learning does not work. So in real time, if you want to make very fast decisions, you have to go ahead with deep learning. So deep learning is quite complex, as the name indicates. It's quite complex, but then the advantage is it's very accurate. That's the thing. So one example I can say here is self-driving cars. So there you have to immediately decide what should be done, right? So there we can go ahead with deep learning. Now you have agentic AI and all that coming up, but then this is how it is for now. Then here you have an example here. Please don't speak, or I'll give you the mic next. Yes. So you have machine learning here. So you have a data set here. I think it's visible there. So you have actually Microsoft slides, copyrighted slides for AI. That's topic called AI 900. Okay, these slides are for them. So that is a flower. Okay. Then you have names to them. So how many parameters do I have? There is an image of a flower and a name. How many parameters are there? I give you the answer. How many? How many did I say? There is a flower image plus there is a name. How many parameters are there? Flower image is 1. Then name is 2. So how many parameters are there? I told the answer just now. What is the answer? It is 2. See, parameter is nothing but you can imagine data set like your roll number, your attendance sheet. You will have seat number, you will have your name, you will have roll number. What else will you have? Department, section, all that. Attendance sheet part is there. You've seen, right? Give me one reaction. So that is a data set. You can see you have it is sorted from A it will start. So you have serial number, you have your roll number, then you have name, department and all that. So that is similar to that of a data set here. So that data set, what you do here is you have here this particular data set, which consists of the image of a particular flower plus a name. Okay, I'm going to feed it into a machine. Okay, okay, this is done. So I'm going to see this part is called training. Okay, the next part, what do we call it? You have learned machine learning, right? Okay, it's fine. We can learn it today. So the fifth part is called training. See your semester exams, 5 units they'll teach you. Then they'll conduct something. What is it called? Semester, which is nothing but test. So training comes first, then you have something called testing. So now you're going to test if the model is successful. I'll show a flower image. It should be able to correctly predict the name of that image. In that case, my model is successful. You're able to get it. So I have trained my model with a name and also the image of that particular flower. So after training, I want to know if the model is successfully trained. So what I do is I show any one of the flowers which I have just trained. Then if it is possibly able to say the correct name of it, my model is successful. Otherwise, you have to redo it. Right? That is machine learning. As I told you, you will have a historical data set, and that data set, what happens is you will get future insights out of it. For example, if it's a mark sheet, you have a CGPA calculation there. So you have a lot of marks from which you will be able to get, okay, this particular student will top the class, right? So you have a data set from which you get the future insight. Then the next thing is, then I think you will not learn machine learning, right? So we'll just skip the whole process. Let me just make it very simple here. So we have three models. We have three types of learning here. One is called supervised learning. One is called, if there is supervised, there should be unsupervised. The third thing is called reinforced learning. Okay. Supervised learning is nothing but what happens in your classroom. If you have an exam, there will be a person to monitor the exam, right? So you need a supervisor for that. That is supervised learning. For unsupervised learning, you don't need a person there. Just randomly pattern will see. The third thing is called reinforced learning. Reinforced learning is very quick supervised learning. Whenever you hear a term called real time, then you have to remember it is reinforced learning. For example, how many of you play Free Fire or PUBG, chess? What are the games you play? Free Fire, okay. Anybody else? I'm just asking you the game. What do you play? Colin? You don't play games? Oh, fine. What do you don't play any games? You always study. What do you do? Don't have phone. Good boy. Okay. Anybody else here? What games do you play? Okay, Free Fire. Very good. Anybody else? All these people. Okay. Then here. Okay. See, there are a lot. It's okay. You can say what game you play. Anybody from that? What do you play? What do you play? You don't play. It's okay. We don't tell it to your parents. Yes. Yeah. Oh, very good. See, listen here. You play something which requires a real-time person there. If you are only one person, it will automatically allocate the other person. The very first time you play chess, you will win. The game will lose. The reason it will understand your moves. From the second time, AI will win. You won't win. It will become complex. Try next time. First install chess. From the second time, it knows your moves, which one you will move, right? So here, the output of regression is numerical in nature. Wherever you have numbers, that is the output of regression. We were speaking about cotton goods, how many will get sold out, weather forecast, stock market, which stock will go up, gold prediction, gold might estimate be right. For example, if gold might reach 1 lakh in 2 months, such prediction, whichever involves numbers, we call it as regression. Okay, here we have a data set. So regression and classification comes under Supervised learning. See the training test we saw right now, right? That is a part of supervised learning. Only when you have for example, if you are learning it from YouTube, there is no training test and all. Directly you will learn, that's it. For example, if you are learning in a college, you will have training and testing, which is training is your throughout the semester they'll teach you, and in the semester they'll test how much knowledge you have in that particular subject, right? So here regression is supervised learning. So it's a data set. How does it look? We have two parameters here. What is the first parameter? 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 Okay, very good. It's better, very good. Second one, how does it look? Cycle, very good. See, it's cycle rental data set. If the weather is 70, how many cycles were rented? If the weather is 50, how many cycles were rented? Okay. So here, what we are going to do is, as I told you, we are going to do training and testing. So the very first thing is you have a big data set. You divide it accordingly. See, we are dividing it. The first part is for training, second part is for testing. Testing is otherwise called inference or validation. Okay. So the first part we are going to do plotting here. What is the data set? It's you. What's your name? Venkatesh, please tell me what is the data set. Yes. It's okay, give it a try. What is the data set? I just told. You can ask any of your friends and tell. What is the data set? Say others listen. So we have a whole data set that is divided into two. First half 60% for training, second half is for testing. See, testing is otherwise called validation or inference. Recently, we don't use testing, validation or we call it inference in IT. Corporately, that's how we call it. You know, Rinki? Sit down. So here we are going to plot it. Okay, we are plotting it. So we'll randomly get a formula. Okay. So here we are going to predict it. There is one thing I cannot change. Is it the weather or the cycle rental fees? What is it? We have two variables here. One is the first thing. Second one is the rental thing. Okay. So which is a dependent variable? Which is the independent variable? Yes. Pass. See, temperature you can't control, so that is independent variable. So, for example, if it's a holiday tomorrow or not, it depends on the temperature. Temperature you can't change, but the holiday depends on your temperature, right? If it is very low, there's rain everywhere. The collector will announce holiday. So here also temperature cannot be changed, which is x value. You can see the first value is x. The second value is the cycle rental. So you just go for this. See, can you tell me what is, see, you can apply, instead of x, apply 54 and tell me what is the value. Instead of x you can see here, 35 plus 1.5 into x. You can use your phones. You have phones, right? You have phones, right? Yes, no? Give me one reaction. Yes, no? Yes, you have, right? So, instead of x here, you have 35 plus 1.5x. Instead of that x, apply 54 and tell me what's the output. Fast, fast. Yeah, it is 116, right? So if you can see here. See here, for 54 it was 116. See the 114 is the actual value. 116 which you told right now is called the predicted value. Can you understand? 116 is computer predicted value while 114 is the actual value. So you can see your model is somewhat successful. It's not equal. It's not 100% successful, but then you can say it is like at least 80% successful. So this is how you start predicting things. Okay. So overall, what is the output of regression? It is numbers, which numerical in nature. So we go to the next. So classification is nothing but the output is 0 or 1, which is binary, true, false, 0, 1 or anything. For example, if you are planning to go to some other symposium, the output should be yes or no. Right. For example, if you give a medical report, for example, for thyroid checkup or something, the output is yes or no. COVID, positive or negative, right? Yes or no. So wherever the output is yes or no, so classification comes and plays a vital role there. Okay. So here also you have this classification also is supervised learning. So what do we do? The data set is split into two. One is for testing. One is for training. Yes. Just see into it. It's quite complex. Just see how it is done. So I split the data set. I'll just do it again. See, here you have a data set, medical data set. You can see above you have test tubes and all that. Then the second thing is you split it into two. Then you plot it here. Then you find a value. You have two values here, right? You can see here. So it has predicted two values correctly. Two values are not correct. Okay. So right side last, you can see 0, 1, 1, 0. That is a prediction. This side, no, it's the actual value. Okay. So whenever the output is binary, 0, 1, 2, 4, it is classification algorithm. Whenever the output is numbers, it is regression algorithm. And finally, you have clustering. Clustering is nothing but grouping. Morning, I was telling you an example here. It's nothing but grouping. We have a big data set, we just group here. For example, the whole college assembles here. We'll say CSC comes this side. And maybe mechanical comes side, like that. We make them streams, right? So it is grouping. We don't train anything there. So there you have clustering. The recommendation systems are an example of this. Then, yeah. So you can see there, it started like this. Then it has finally found the patterns. It has fine-tuned, and finally you have this. Okay. Then we'll see this computer vision. See, whenever the input is image, it's computer vision. So can you tell me what are the things you see here? Yes, car. 1 o'clock. Yes, fast. Yeah, you see cars, then okay, you can right side you can see two people in the cycle, then okay, trees, then if I ask you to explain the image in one sentence, how will you explain? Okay, it is a road. How do you say it is a road? If you have correct. You have the traffic signal there. So you are able to analyze the image, right? What is there you are able to analyze. So this is not possible by a machine. What we do here is we just divide the image into pixels. There are totally 256 pixels. Since it is a machine, everything starts from 0. Say like array of 10. It starts from A of 0 to A of 9. Similarly here there are totally 256 pixels and you have 0 to 255 degrees. Let me show you. So you can see here, it is broken into pixels. That too, if you see down, you can see 3 boxes are there, which is nothing but red, blue, green, the primary colors. So everything is divided into pixels. The value, what is the range of the pixel? It is 0 to 255. So that's total number of pixels. How much is that? It is 256. This is common for every computer vision, 256. Okay. Then you have this. So these are the applications of computer vision. Okay. First thing is image classification. If I have to learn animal kingdom, I show a particular image to say it's a dog or a tiger, such things. Second thing is object detection. Object detection, for example, you have Snapchat. Okay, how many of you use Snapchat? Snaps use. Nobody else uses it. You all have a phone. You have Nokia. Which one? You have this that phone. They used to have earlier. Which phone do you have? Smartphone. Very good. Which company is it? We hope. Okay, fine. Listen. It's fine. Listen. You all have phones, right? See, the first thing here is if you use Snapchat, if there are three people here, understand the question. See, if there are three people here, and if the box is only for two people, you are applying some filter. The box is only for two people. Only two people will get the filter. The third person will not get the filter. Have you tried? Girls will know for sure. How about here? Everywhere boys used to speak here, girls are at least nodding here. See, you people are like statues here. Okay, fine. Listen. So it's object. See, it's face detection. In Snapchat, it's face detection. Is it AR or VR? Augmented reality or virtual reality? See, in Snapchat, we are using AR or VR. Yes. How many of you think it's VR? Virtual reality. It's okay, you can raise your hands. Yes. How many of you think it is augmented reality? Others don't even think. I think you should speak. Let it be even wrong, but you should try speaking it out. Let it be wrong. It's fine. You should try to volunteer. See, it is. See, virtual reality is something. It's completely in a different environment. Everything. The headset, if you wear, it is completely in a different environment. That's what happens there. In augmented reality, it is a real world image or environment where you have external things there. In Snapchat, you have your own image plus a filter, maybe a cooler there. So it is augmented reality. Okay, you have to know the difference. Okay, done. That is object detection. The next one is called semantic segmentation. Semantic means similar. Whichever is similar, we group it. How do you say you are happy? Which language do you speak? Telugu. How do you say you are happy? How do you say you are happy in Telugu? Sandosham. Okay. Here, how do you say you are happy? You are happy. It's okay. Try it out. How do you? Yes. How do you say? See, this word you can say everybody. How do you say you are happy? How do you? Yes. Anandam. Very good. Okay. Sandosham Anandam. Here, you people will never was like not even once were happy in your lifetime. What kind of reaction is it? Yes. How do you tell happiness? Yes. See, all of you got placed. How do you explain it to your family? How do you speak? What is the word you say? How do you say it? You won't say it. You won't say it to your family. You'll escape. Yes, here, how do you say fast? Fast. How do you say you are happy? People, you should start speaking out, especially girls, you should start speaking out. You should have your own voice. Otherwise, you will remain just like this in future also. You need a voice. You need a job. Yes. How do you say you are happy? Sandoshama. Yes. Chala Sandoshama. So he is very happy then. Yes. How do you say you are happy? Yes. Yes. What is the term you use to say? Past. How do you say happy? This crowd is quite different here. Okay, listen. See, there are few words. As he told, Sandosham, Chavu, Sandosham, or Anandam, or however. So, those words, no, every word means the same thing, right? Which is happy, right? So, here in semantic segmentation, you can see both the trucks or car are in the same color. The cyclist, the last two people, they are also shaded in the same color. What if I have a car coming in, new car coming in? What will be the color? See, listen to the question. See, similar things are grouped here. As I told, happy, three words they told, every word is, the meaning is same. So we just group it. Here you can see the colors. Red color is coded for bus, right? So both the buses are red color. If I have one more, that will also be in red color. If I have one more car, which color will it be? Yeah, very good. It is blue because already you have one, you have it in blue, right? The next thing, let's go to the next thing. Image analysis. Image analysis is nothing but giving a caption to a image. For example, you have something that they'll give live commentary, you have live subtitle, right? In YouTube, live subtitles. Such things are also AI. They'll predict things and give you. Then the next thing is face detection and recognition, which is like Snapchat. See, in few phones it will say, they will detect the face and say, this, okay, female, this is the age, they are happy and all that, right? That is also application of computer vision. The final thing, okay, OCR is where image is taken as the input, output is the characters in it. We saw this example here. What is it? How do you write exams? You take a photo of that particular thing, all the alphabets are taken. So, application of OCR, what is it? What is the application of OCR? Google, yes, up there. What is it? In specific. If there is an exam, what do? You take a photo, right? What is it? Google Lens, right? Google Lens, you take a photo, then it extracts only the alphabets, right? So that is the application of optical character recognition. Okay. Moving on. Then you can see here, it has something called, it detects the face of the person. Then okay. You have to detect the face of the person, age and all that. Apart from that, it also detects the happiness level, right? There is a number there nearby. It's 0.75 or something. We call that as a confidence score. So it is how confident the system is telling this particular output is correct. And moving on. This is handwritten text recognition and all that. Let me come here. This is NLP where we do something called sentiment analysis. If you go to the hotel, write a review. That review is taken as the input, and we do something called sentiment analysis. Can you tell me a sentence? Any one of you? Have you been somewhere IB or something? I learned Python. I'm very sad. You learn Python, you're sad now. Different sentences. It's okay, let me give you a sentence. It's okay, I'll give you a sentence. See, listen here. Okay, that's a sentence here. Okay, is this happy or sad? See, the sentence is I had a wonderful vacation in France. Okay, so is it happy or sad? How many of you think it is happy? Give me a reaction, guys. Is it happy or sad? See, if you go to France and if you have vacation there, how will you say it? Oh my. Yes. Ah, children, tell me. Even children speak a lot. Happy, no? See, imagine yourself being in France and you're sending, okay, these pictures and you tell your family, I'm here in the vacation, it is happy. How do you tell it? It's positive or negative? Yeah, it's positive. He's in France already. Okay, listen. So there is a sentence here. Using the sentence, I predict if it is positive or negative. That is called sentiment analysis. If I say, she told, let's take the sentence. I learned Python. Is that positive or negative? Positive because you think you'll get a job. I'm asking about the sentence. I learned Python. Today is Wednesday. Okay, this sentence is positive or negative. How many of you think it's positive? Okay, good. See, it is neither positive nor negative. So it is it's neutral. Right? So if there is a sentence I give. Listen here, I give a review. The location of the hotel is very good, but then hospitality is not good. Is it positive or negative? I said location is good. So that is something positive. That is something negative. What usually happens is it will grade positive this much percentage. This is the percentage. For negative, this is the percentage. Or neutral, this is the percentage. That's how it is. So see here, the first thing we do here in text analytics is we'll detect the language. The second thing is the sentiment, 88% positive. So the words which I used to say is positive or negative, we call it as a key phrase. Okay, wonderful location. So the third thing is entity is nothing but a noun, or it could be a place, or it could be a celebrity or whatever. You're able to understand? See, NLP, we have wherever text is input, that is a part of NLP. So it will analyze things like this. If you ask Alexa, Siri, and all, they analyze the sentiment of the particular sentence you say using this particular platform. Then the next thing is then is speech recognition synthesis. You know, Siri, Alexa, you speak, it get back. And that is one thing. Translation. Google Translate is the example here. Then the next thing. Okay, see here, that's the difference here. See, there was no output or action in the previous thing. But here there is output. Which is, if I say turn off the light, somebody will turn it off. There is an action there. So that is called intent. There is the intention there. Intent type with the program. In IoT, you would say smart AC, turn the light settings to move it or something like that. It will change the light settings, right? So input there is again speech or text. We call it as NLP. It's the application of NLP. So here you can see switch the light on. So the whole sentence we call it as an utterance. Okay. So utterance is nothing but the whole sentence. We also saw the language detective. What's the language? Which language is it? Okay. Which language is sleepy? You. Which language is it? No, the screen. You please. Yes, you. What is written on the screen? Oh, read the sentence, please. Tell me, yeah. You can ask somebody and say. One of you say, okay, please. Now, Akash. What is the song? Yes, what is the sentence? Hey, just read what is there. Okay, switch the light on. What will happen if I say the sentence? First, switch the light on. If I say what will happen? They will turn on the light, right? That is the intent there. Can you give next? Give next. PPT. Sir. Ambi. Next. Sorry. No, you change the PPT. You change the PPT. Previous PPT, I said next. I was not having the sensor, it was not working there. Shift F5. Enough. That was. Hey, give F5. Okay, listen here. So you can see here, this was a sentence, right? So you can see that is entity. What is entity here? Light is the entity. So the output of this sentence is it turns on the light. So we have something new called intent. Intent is nothing but action which can be performed. Sleepy, you green shirt. Okay. Okay, listen. So this comes in IoT. We just finish it up. So conversation A, which is a lunch time. What's a lunch time? 1 o'clock. You people sleep even before lunch. So what will you do after lunch? Continue sleeping. So we have 10 minutes more. With this, we'll finish it up, okay? Conversational AI is nothing but ChatGPT. What is the input of conversational AI? Yes, what is the input of conversational AI? Yeah, it is prompt. What is the output then? It's a dialogue, that's it. ChatGPT is the example. Okay, finish this one. Go to that. Okay, listen. So these are the few opportunities which we can have as a fresher. One is AI data analyst. You can learn Power BI or even Excel. You can learn that. Then you have junior ML engineer, whichever we spoke right now, you can do that. Then you can have prompt engineer. Then you have AI trainer. These are few of the roles which you can do. There are so many roles, but these are the roles which are gaining momentum, which can get you at least 40K initially itself. So you can choose one job which you like, and then you can just proceed on. So you can see how much payment you can get for that. With that, let's finish it off. Thank you. Is there any doubt? Were you able to understand something like